Welcome everyone to this course. This course is all about how to create our project real-time face recognition using YOLOv7 in the RoboFlow website. So this course consists of different classes. In the first class, we are going to discuss about how to create an account in the RoboFlow website and also how to create an project workspace in the RoboFlow website. In the second class, we are going to discuss about how to create data set for our project real-time facial recognition with the different kinds of methods available in the RoboFlow website. In the third class, we are going to discuss about how to annotate these images for our project with the different kinds of tools available in the RoboFlow website. In the fifth class, we are going to discuss about how to train the dataset images with the YOLOv7 model in the RoboFlow website. In the last class, we are going to discuss about how to validate these dataset, and also we are going to discuss about how to run this project in the PyCharm IDE. So this course is very useful for if you want to create a project in the machine learning and also deep learning. You have to first familiarize yourself with the RoboFlow website and also Google Colab website. For that only, I show you complete details of the RoboFlow and also Google Colab for our project. So let's get started. Welcome to the first class. In today's class, we are going to discuss about how to create an account in the RoboFlow website, and also we are going to discuss about how to create our project in the RoboFlow website. So these are the topics we are going to discuss in today's class. So let's get started. For creating an account in the RoboFlow website, you have to select sign in option. After that, you have to select your Google account for signing in the RoboFlow website. After signing, you have to create project in the RoboFlow website. For that, you have to select create new project option. In that, you can see three types of features available in the RoboFlow website for creating your project. The first one is the object detection, and the second one is the classification, and the third one is the instance segmentation. In the first object detection, it detects the multiple things and their specific locations like the person, back or any other objects. And the second one is the classification. It classifies the images and also assigns labels to them. And the third one is the instance segmentation. It detects the multiple objects with their actual shape. Like in the example, you can see the fish actual shape is detected. For that, we are going to use the object detection for our project. After that, you have to type your project name. Our project is about real-time face detection using the YOLOv7 model. For that, you have to type your project name real-time facial recognition. After that, you have to type what are you detecting. We are going to detect the faces in the RoboFlow website. After that, you have to select any one of the licenses in the given options. After completing all the options, we are going to create the project. For that, you have to select create public project. So that's it. In today's class, we have discussed about how to create an account in the RoboFlow website, and also we have discussed about how to create our project workspace in the RoboFlow website. In the upcoming class, we are going to create a data set for our project real-time facial recognition with the different types of methods available in the RoboFlow website. So let's see you in the next class. Welcome everyone to the second class. In today's class, we are going to discuss about how to create data set for our project real-time facial recognition using YOLOv7. For that, we are going to use different types of methods in the RoboFlow website. So let's get started. For creating the data set in the RoboFlow website, you can see different types of methods. The first one is the select files. We have to drag and drop all the files. After that, you can see the select folder option. You have to drag and drop the folders which contains the images files. For that only, you have to select the select folder option. After that, you can see the third option available in the RoboFlow website, that is import YouTube video. You have to type your YouTube video link or URL for your dataset. After that, you can see the another method available in the RoboFlow website. that is the Find Universe dataset. You have to open that link. So in that you can see RoboFlow itself contains millions of dataset for your project. You can also view the dataset, images and models available for your project. After that, we are going to import our dataset for our project, that is the facial recognition. For that, I created two different MPV4 files, that is the video files. We are going to import that dataset for our project. So you can see the two sample videos which contains the facial images of the dataset. So we are going to detect these faces for our project. For that, you have to drag and drop these two videos for your dataset. After that, you have to create frames for your dataset. If you increase the frame size, the output images will be decreased. If you decrease the frame size, the output dataset images will be increased. For that, we are going to decrease the frame for creating more dataset images. So I am going to decrease the frame size for 19 frames per second. You can see 260 images created for our dataset. If you want more dataset images, we can decrease more amount of time in the frames. After that, you have to select choose frame rate. In that, you can see 260 images are created from the video. Again, you have to select frames for the second video. So you have to decrease the frames to create more number of images. After that, you have to wait for the RoboFlow website to upload your dataset. Next method to create our dataset, that is downloading the images from the Google Chrome. For that, you have to type your dataset name in the Google Chrome. For my project, I am going to select the Tony Stark face images. In that, you can see the face images of the Tony Stark. For downloading these dataset, I am going to show you an extension which is very helpful to download all the images. That is Image Assistant Batch Image Downloader. You have to download this extension and add this extension to the Chrome. After adding this extension, you have to open the Google Chrome and right click. You can see the Image Assistant extension. You have to select Extract Current Page. So in that, you can see all the images extracted from the Google Images. So you have to select all and select Download Selected. At last, you have to select Continue. So you can see all the images downloaded for your project. So these are the images downloaded from the Image Assistant's Batch Image Downloader extension. So you can also drag and drop these images to your project. After that, you can see the total amount of images for the annotation. We can also view the 370 images for our annotation. At last, you have to select Assign Images. So that's it. In today's class, we have discussed about how to create data set for our project, real-time facial recognition. In the upcoming class, we are going to discuss about how to annotate these images for our data set. So let's see you in the next class. Welcome everyone to the third class. In today's class, we are going to discuss about how to create annotations for your project in the RoboFlow website. And also we are going to discuss about how to annotate images with the different kinds of tools available in the RoboFlow website. So let's get started. For annotation, you have to select Start Annotation option. In that, you can see the dashboard of the annotation. In the left side, you can see the different kinds of options available. The first one is the annotation, and the second one is the attributes, and the third one is the comments, history, and the raw data. In the annotation, you can see two files, that is the classes and the layers. In the right side, you can see different kinds of tools for creating annotations for your project. We are going to discuss one by one. And the first tool we are going to discuss is about the drag tool. It drags your images for your convenient one. After that, we are going to discuss about the bounding box tool. It creates the bounding box region to detect the faces for your project. You have to type the class name and save enter. That is the class name of Tony Stark. So this face is for the Tony Stark. Again, you have to create bounding box to create the face for the another class, that is Hulk. So this face shows the class Hulk. We are going to discuss about the next tool, that is polygon tool. It creates the polygon line for your project. So you have to create polygon lines to detect the face portion of your dataset. After that, you have to type the class name and save enter. The class name is Tony Stark. Again, you have to create polygon tool line for the another face images. So you have to create polygon line one by one. You have to type the class name, that is Hulk, and save enter. After that, we are going to discuss about another tool, that is Smart Polygon. It is an AI feature of the RoboFlow website. In that, you can see the two options available. We are going to use the standard option. In the Smart Polygon, you have to select the portion of the region for your dataset. Also, you have to uncheck the unwanted portion for your project. The green portion shows only the dataset is created for that class, and the red shows in the unwanted portion. It does not include for your project. So you have to create green dots for creating the portion of the face. Also, you have to use the red dots to remove the unwanted regions. After that, you have to select finish enter and type the class name. You can also select any one of the class name for your project. After that, we are going to discuss about the other tools available in the RoboFlow website, that is label assist and the repeat previous. Previous is a very useful tool to create the previous activities you have done in the previous image. That is, you have created annotations in the previous images. So you have to use the repeat previous tool to reduce the amount of time in the annotation. After that, you can see the command tool and redo, undo, and the last one is the mark null. It removes all the annotations you have done in that images. You have to select mark null. It creates nothing for your annotation. You can also use the repeat previous to reduce the amount of time. For the most, we are going to use the bounding box tool for creating our dataset for our project real-time face recognition. So you have to create bounding box for the each classes. Also, you can use any number of tools for creating your project. Mostly, I use bounding box and repeat previous to reduce the amount of time in the annotations. After annotation, you can see the annotated images in the RoboFlow website. That is 317 images annotated for our dataset. After that, you have to select add 317 images to the dataset. In that, you can see the train percentage, valid percentage, and the test percentage. The train is about 70, valid is about 20, and the test is about the 10%. You can also increase or decrease the percentages. For that, we are going to increase the train percentage. Also, you can view the images. At last, you have to select add images option. So that's it. In today's class, we are discuss about how to annotate your dataset for your project real-time face recognition using any dataset created in the RoboFlow website. In the upcoming class, we are going to discuss about how to train these dataset with the YOLOv7 model in the RoboFlow website. So let's see you in the next class. Hello everyone, in today's class we are going to discuss about how to train our dataset with the YOLOv7 model in the RoboFlow website. So let's get started. For training the model, you have to create version for your project. For that, you have to select create new version from the generate option. Also, you can see the source images and the classes you have created, and also you can see the train, test, validation, testing images. For the pre-processing, you have to select continue option. For the augmentation also, you have to select continue. At last, we are going to create project. For that, you have to select create. For training the model, you have two different options. The first one is the train with RoboFlow and the second one is the custom train and upload. In the train with RoboFlow, you can see the available credit points for training the dataset. For the available credit points for the first account you have created, that is 3. After that, you can see the images for your dataset. Before training the model, you have to download the dataset. For that, you have to select export dataset. In that, you have to select the format. We are going to select the YOLOv7 PyTorch file. You can also see any number of models available in the RoboFlow website. We are going to select YOLOv7 PyTorch file, and also you have to select the download zip to computer. After that, you have to select continue option. After downloading the dataset, you have to select train with RoboFlow. In that, you can see two different options available. The first one is the fast and the second one is the accurate. We are going to select the fast option only. After selecting that, you have to select continue. You have to select the recommendation and you have to select the recommended option. After that, you have to select the start training option. So you can see the model is training in the RoboFlow website. You have to wait for the training options completed in the RoboFlow website. After completion of the training, you receive an email notification from the RoboFlow website. After that, you can view your model in the RoboFlow website. So that's it. In today's class, we are discuss about how to train our dataset with the YOLOv7 model for our project facial recognition using YOLOv7. In the upcoming class, we are going to validate this trained model in the RoboFlow website. So let's see you in the upcoming class. Welcome everyone. In today's class, we are going to discuss about how to validate the trained model in the RoboFlow website. In the previous class, we are discussed about how to train the model in the RoboFlow website. So let's get started. After training the dataset with the YOLOv7 model, you can see the percentage of mean average precision and recall. In the mean average precision, you can see 96.0% and the precision is about 90.9% and the last recall is about 94.2%. So it shows around the successful of our project, that is real-time face recognition. For that, I am going to use drag and drop option. I am going to drag and drop any one of the images to validate my dataset. So you can also increase the threshold percentage and overlap confidence threshold percentage to increase the percentage of the predictions. So it shows around 94% of the Tony Stark. So our project is very successful to detect the facial recognition. Also, you can drag and drop any of the images to validate. So I am going to drag and drop these images. So it shows around 94% of Thor face recognition. Also, you can drag and drop any number of images to validate your dataset. So it shows around the Captain America, Agent Hill and the Doctor percentage. So you can also drag and drop your video to validate the dataset. For that, I am going to drag and drop the video. So it shows around 94% of the Thor, Marvel, You can also recognize the face in the images. So your YOLOv7 model is very well trained with the data set created from the sample videos. So it is one of the sample. You can also create data set from any number of images. Also you can train with the models available in the RoboFlow website. So that's it. In today's class, we are discuss about how to validate the trained YOLOv7 model for our project face recognition using YOLOv7. In that you can see the validate model shows 94%. So it is a successful one. So in the upcoming class, we are going to discuss about how to run our project in the PyCharm IDE. So let's see you in the next class. Welcome everyone. In today's class, we are going to discuss about how to run this project in the PyCharm IDE. So let's get started. For running the project, you have to select code snippets. In that you can see different types of methods. The first one is the hosted API, and the second one is the on device. And the third one is the native SDK. You can use OpenCV to run your project. You can also view the code available for your project. So it shows around the OpenCV for your project. And the fourth one is the cloud. And you can see the Azure virtual machines and the GCP compute engine. And the last one is the utilities. So utilities is very useful for running most of the projects for your model. That is, first one is the annotate prediction, and the second one is the blur prediction, and the third one is the count predictions, and the fourth one is the counting zone, and the fifth one is the count across line, and the last one is the use SAHI. So we are going to discuss this one by one. For the first one, we are going to use the hosted API. We are going to use the API from the RoboFlow website to run the project in the PyCharm IDE. For that, you have to select the Python. You can also view different languages like Curl, JavaScript, Swift, and .NET. You have to copy the Python code. And you have to open the project folder. You have to right click and open with PyCharm IDE. After opening the PyCharm IDE, you have to create Python file for your project. You have to type your Python name. After that, you have to copy paste the code. Before running the project, you have to select the Python interpreter. For that, you have to select settings. In settings, you have to select the project. In the project, you have to select the Python interpreter. For my project, I am going to use the Python 3.9 because it shows no errors for running the project. After that, we are going to type the JPG file name, and also we are going to rename the JPG file name for our convenience. For that, I am going to select any one of the images and refactor and rename that image. After that, we are going to discuss about the code explanation for our project. In the first one, we are going to import the RoboFlow package. For that, you have to install the RoboFlow package. After that, we are going to import the API key for our project. In the third line, we are going to discuss about the workspace, and the fourth line, we are going to import the model for our project, that is YOLOv7 model. In the 7th and 10th line, we are going to predict the images, and also we are going to save the images for our project. In that, you can see the confidence level, and also you can see the overlap levels. After that, you have to run your project. For that, you have to right click and select the Python project. In that, you can see the Python RoboFlow package, workspace, and project is imported. At last, you can see the output for the project. In the output, the class shows the marble. In that, you can understand that images consist of the marble face. For that, you have to open the c.jpg. You can view the detected face. So that is Marvel JPG. So it shows Marvel. After that, you can also type another JPG file name to validate the dataset. You have to again run the project. In that you can see the class is store. You can understand that the predicted images in that JPG is the Thor image face. So you can view the predicted images. After that, we are going to use one of the utilities code for our project, that is count predictions. We are going to copy this code to run our project. For that, you have to copy the code and create the new Python file. You have to type the Python name file. You have to copy paste. You have to rename the JPG file name. So we are going to detect the classes present in the JPG. We are going to detect two faces. After typing that, you have to run the code. In that you can see two classes are detected in that JPG. In the real image, it shows the two faces, that is Hulk and the Tony Stark. For that only it shows the two classes are detected. After that, you can use any number of utilities code for your project, that is annotate prediction, blur prediction, count prediction, count in zone, count across line, and use SAHI. In the count in zone, you can use your MP4 files to detect your project. You can also copy this code and run the code in the PyCharm IDE. Before running that, you have to install the packages required for that code. So that's it. This course is all about how to create our project real-time face recognition using YOLOv7 in the RoboFlow website. In the first class, we have discussed about how to create an account in the RoboFlow website and also how to create a project workspace in the RoboFlow website. In the second class, we have discussed about how to create dataset for our project. In the third class, we have discussed about how to annotate the dataset for our project. And the fourth class, we have discussed about how to train the dataset with the YOLOv7 model in the RoboFlow website. In the fifth class, we have discussed about how to validate the images in the RoboFlow website. In the sixth class, that is the final class, we have discussed about how to run the project in the PyCharm IDE. And also, I have created classes for how to generate the PyTorch file from the Google Colab. For that, you can also view the Google Colab to generate the PyTorch file for your project. Hope you learned something from this course. And also you have to familiarize yourself with the RoboFlow website to create n number of projects in the machine learning and also deep learning. Hope I can see you in the upcoming courses taught by me. Welcome everyone to the first class of second module. In today's class, we are going to discuss about what is Google Colab and why do we use Google Colab for our project detecting helmets in the surrounding place using YOLOv7. So these are the topics we are going to discuss in this class. So let's get started. So why do we use Google Colab for our project? Google Colab consists of free GPU and TPU for training our model in the cloud platform. If you don't have any strong GPU for training your model, you can use Google Colab for training our model. For that only, we can use Google Colab for training our model with a free GPU and TPU. For our project, we have to create new file in the Google Colab. You can see the dashboard of the Google Colab. After that, you have to type your project name in the Google Colab. For my project, detecting helmet in the surrounding places, I am going to type the name YOLOv7 helmet detection project. After that, you have to create runtime for your project. you have to select runtime. After that, you can select change runtime type. In that, you have to select Python 3. After that, you have to select T4 GPU. For training the model, you have to note that we have to use T4 GPU. After that, you can select save. After saving the file, you have to connect the T4 GPU for your project. You can see the options available in the right corner of the Google Colab. After connecting the T4 GPU, you can see the RAM and disk running for your project. So that's the most important thing of the Google Colab. It consists of free GPU for training our model. If you don't have any strong GPU for training your model, you have to use the Google Colab for training the model. So in the upcoming class, we are going to discuss about what are the files necessary for our project and how to import that files in the Google Colab. So let's see you in the next class. Welcome everyone to the second class. In today's class, we are going to discuss about what are the files necessary for our project and how to import that files in our Google Colab. So these are the topics we are going to discuss in this class. So let's get started. For the first one, we are going to import the YOLOv7 main package to our Google Colab. For that only, you have to type this command git clone https github.com YOLOv7. So this package is available in the github.com. In that, it consists of different kinds of informations all about the YOLOv7. So it shows the images, also codes for our project. So for that only, we are going to import that YOLOv7 in our Google Colab. You can also see all the files are imported from the github.com. After that, you have to type cd YOLOv7 for changing the directory to YOLOv7. After that, you have to type pip install requirements.txt for installing the requirements for running our project. After that, you have to select run. After running your project, you can see the YOLOv7 is cloning into your project. You can also see all the requirements satisfied for your project. After that, we are going to import the RoboFlow project in our Google Colab. You have to type this command. For this command, you have to open the RoboFlow website. In that, you can see the export dataset option. You have to select show download code. You can see the code available for importing the RoboFlow website. So you have to copy the code. After that, you have to paste that code in the Google Colab project. You can see the API key for your project, and also you can see the project name and workspace name you already created in the RoboFlow website. After that, you have to select run option. After the successful import of RoboFlow package in the Google Colab, you can see the folder available in the YOLOv7. You can see the folder consists of our project name, detecting helmets. You can also see the dataset for training, test and valid. Also, you can see the YAML file and the txd.files. In each folder, it consists of images and labels we have created, annotated in the previous class. In the last step, we are going to import the YOLOv7 PyTorch file for our project. For that, you have to type this command cd/content/YOLOv7 for changing the directory. After that, you have to type wget for getting the files from the GitHub. We are going to fetch the YOLOv7 PyTorch file from the GitHub. After the typing the command, you have to select run. At last, you can see the YOLOv7 PyTorch file is saved in your project folder. So that's it. In today's class, we have discussed about what are the important files to be imported for your project. In the first one, we have discussed about how to import the YOLOv7 main package to our project. And the second one, we have imported the RoboFlow project for our Google Colab. In the last step, we have imported the YOLOv7 PyTorch file for our project. You don't have to worry about the codes for importing the packages. I have created a notepad file. It consists of all kinds of codes for our project and also included in our course. So in the upcoming class, we are going to see about how to train our model in the Google Colab. Welcome to the third class. In today's class, we are going to discuss about how to train our model in the Google Colab. In the previous class, we have discussed about how to create the project in Google Colab and how to import the important files for our project. In today's class, we are going to see the most important feature in the Google Colab, that is training the model. So let's get started. For training the model, you have to type these two commands for your project. The first command shows cd content/YOLOv7 for changing the directory to YOLOv7. After that, you have to type this line for training the model. The first one shows the Python and the second one shows train.py. The train.py is available in the YOLOv7 main package. After that, you have to type batch size 16. You can also type any number of batch size for your project. After that, you have to type CFG, that is configuration. So configuration folder is also available in the YOLOv7 main package. In the configuration folder, you can see the training folder. After that, you can see the YOLOv7 YAML file. After that, you have to type epoch for your project. The most important tip for epoch is you have to type more than 300 for more accuracy and precision for your project. For the sample only, I have shown 100 epochs. After that, you have to type the dataset location and also you have to type the data.yaml file. You can also see the data in the YOLOv7. After that, you have to type the weights for creating the YOLOv7 PyTorch file. In the RoboFlow website, we cannot use the PyTorch file from that website. For that only, we are going to use Google Colab. After that, you have to type the device 0 shows the GPU. If you don't have any strong GPU, you have to use the Google Colab. After typing all the commands, you have to select run. You can see your dataset is training with the YOLOv7 model. After that, you can see the train and value location of your project. At last, you can see the image size is about resolution of 640 x 640. Height and width is 640 x 640. At last, it starts the training for our project with 100 epochs. After the completion of the training, it shows the amount of time required for 100 epoch is 0.57 hours. After that, you can see the best.pt file and the last.pt file is generated for your project. You can use your PyTorch file for your project. In today's class, we have discussed about how to train our dataset with the YOLOv7 model in the Google Colab. For that, we have consists of two different codes for training the model and also it consists of different kinds of options for training the model. The first one is the batch size and the second one is the epoch and the third one is the device. In the upcoming class, we are going to validate that trained PyTorch file for our project detecting helmets in the surrounding places. So that's the topic we are going to discuss about. So let's see you in the next class. Welcome everyone. In today's class, we are going to discuss about how to detect and validate the trained PyTorch file in the Google Colab. So let's get started. For detecting the helmet, you have to type this command. The first one is the Python and the second one is the detect.py. The detect.py is available in the YOLOv7 main folder. You can see the detect.py is available in the YOLOv7. After that, you have to type the weights. In the weights folder, you can see the trained PyTorch file, that is best.pytorch file. After that, you have to type the confidence score for detecting the helmets in the surrounding places. For that, I am going to detect the images with a 0.1 confidence score. Then you have to type the dataset location for detecting the images. At last, you have to select run. After that, you can see the image is well traced with the YOLOv7 model, and it is stored in the detect.exp folder. After the completion of detection, you have to validate the model in the Google Colab. For that, you have to type these commands for your project. For the first one, we are going to import the package glob. After that, we are going to type from ipython.display import image and display option. After that, you have to type for loop command. For that, you have to type I equal to 0 and limit equal to 100. Limit equal to 100 shows that the 100 images must be sold for our project. For the for loop, we are going to list all the images which are detected in the PyTorch file. For that, you have to type the command for image name in glob.glob. After that, you have to list all the images which are in the folder content YOLOv7 runs detect/experiment5.jpg. It shows all the JPG files in that folder. After that, you have to type if I less than limit display image of file name equal to image name, and also you have to type print/n. At last, you have to increment one by one. For that, you have to type I equal to I plus 1. After typing all the commands, you have to run the code. After running the code, you can see the images which are detected with the PyTorch file. It shows the helmet percentage of 0.1% of confidence score. You can also increase the confidence score from 0.1, 0.2, 0.5, any number of amount you can use with your own choice. You can also see the images which are detected using the PyTorch file. In the upcoming class, we are going to discuss about how to download that PyTorch file and how to download the YOLOv7 for our project. So let's see you in the next class. Welcome to the final class of second module. In today's class, we are going to discuss about how to download the PyTorch file trained in the Google Colab. After that, we are going to download the YOLOv7 main package for our project. So these are the topics we are going to discuss in this class. So let's get started. For downloading the PyTorch file, you have to open the runs folder in the YOLOv7 package. In that, you have to open the train folder. After that, you have to open the exp folder. In that, you have to open the weights folder. In that, you can see the best.pt file, that is the trained PyTorch file. You have to right click and download that file. After the download, you can see the PyTorch file is available in the folder. After that, we are going to download YOLOv7 from the GitHub. For that, you have to select code, then you have to select download zip. You have to extract the YOLOv7. In that, you can see all the files available in the GitHub is imported to your folder. After that, you have to copy the PyTorch file and paste the PyTorch file in the YOLOv7 folder. You can also rename the file to your own interest. For that, I am going to rename the file for my project name, that is the helmetdetect.pytorch. So this is the end of the second module. We are going to discuss the third module, how to run the project in the Python IDE using the RoboFlow website. So let's see you in the next module.